Now, one of the very most important things that we need to talk about when it comes to chemistry is energy. Now, energy comes from the electrons. Now, let's talk about types of energy. So we have potential energy, which is energy, like stored energy, like energy that is pretty much like if you shake up a soda that's closed up, there's potential for that soda to move somewhere, and depending on how much you shake it, that determines the spray of the soda. So potential energy is bottled up energy waiting to be used. So answer this question. Which diver has more potential energy? Or think about it like this. Whose splash would be bigger? Then we have kinetic energy, and this is the energy of movement. The diver has now jumped off the diving board and is freely falling, freely moving towards the pool. When we're in regards to electrons, kinetic energy is exhibited when electrons are not bound in a bond. So let's talk about chemical bonds. When you notice here, we have electrons of oxygen and hydrogen being shared here and here. So these electrons are in a bond between these two elements here and here. So these electrons have stored energy. They have potential energy. Now, let's talk about the type of bond this is. Now, remember, carbon has 6 electrons because it has to have the same amount of electrons as it does protons. And hydrogen has 1, if you remember from the periodic table. Now, when you look at this molecule here, you'll see that each hydrogen has 2 electrons connected to it, and this carbon has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 surrounding it. And this is because these hydrogens and this carbon are sharing electrons so that the outermost shell, remember we talked a little bit about the orbitals, and this outermost shell wants to be full. This atom does not want any space unfilled, so it wants to fill it with those electrons. And hydrogen wants just 1 more electron, and carbon just needs 4 more. So it shares electrons with each of these hydrogens. So this hydrogen will share its electron, and the carbon will share one of its electrons with the hydrogen. So hydrogen's shell is full because it wants to, and carbon's shell is full because it's going to share one of its 4 in the outer orbital with each one of these electrons from the hydrogen. This is creating a covalent bond. This is the strongest bond because they're sharing electrons. And when you're sharing electrons, you need that electron to fill your space. You do not want this to be broken. The hydrogen atoms and the oxygen atom also create a covalent bond. But with this, we have a polar covalent bond, because of the electronegativity of oxygen, it wants to pull all the electrons towards it. So it's going to have a negative charge or a negative N. So it's going to be, this is what is called a polar covalent bond. And so this side of the water molecule is going to have a negative charge, almost like a magnet, a more negative charge. And this side of the molecule is going to have a positive charge. Now, this is very important when we start talking about properties of water, because this right here, this polar covalent bonding of water molecules, is what creates some of the properties that we have with water. Again, we mentioned before, this is the structural formula or the molecular formula. It shows what elements are part of the molecule and how many. So this is 1C and 4 H's, 1 carbon, 4 hydrogens. And the formula would be CH4. And this molecule is methane. And that is the molecular formula of methane. You see CH4, and 4 should be a subscript, which means down below that very small 4 that you've seen before. This is methane gas. And so this tells us the same thing, except for we just see it written as if you were like writing it in a paper. Now, all bonds have to deal with electrons. With ionic bonding, we're not sharing electrons. We're bonding because someone wants an electron and someone wants to get rid of one. So here we have an example of just regular old table salt, sodium chloride, NaCl. So with the sodium atom, we see we have this one electron just sitting in this outer shell. And then with this chlorine in the outer shell, instead of having all 6, we have 5. So this chlorine wants to fill that, just like with the hydrogen and oxygen. It wants to fill that space, and this one just wants to get rid of it because it doesn't want to try to fill 5 spaces. It could just get rid of this one. So it is going to find this chlorine. It's going to give this extra electron to this chlorine, and now it's bonded. But because this electron is closer to this chlorine nucleus, it is going to have a more negative charge, and this sodium is going to have a positive charge. Now, when salt goes in water, what happens to it? Right, it dissolves, and when it dissolves into its ions. So the sodium ion is going to dissociate from this chloride ion, and it's just going to be freely floating by itself, all happy with its 10 electrons, and it's going to be a cation. It's going to have a positive charge. Same with chloride, or chlorine now that it's dissociated. It's going to have its negative charge, and it's going to be a chloride ion, an anion, because it's going to have a negative charge. Cation, positive, anion, negative. Now, outside of water, ionic bonds are pretty strong. So we have our salt compound, which is our chloride anions bonded to our sodium cations. And we have hydrogen bonds. Now, you're going to talk a lot about hydrogen bonds in biology. Now, with hydrogen bonds, remember how we talked about our oxygen here being electronegative because it is attracting those electrons towards it, and these ends of the water molecule are positive. Now, that's where the magnet-like quality comes from, because here we have the same thing. And if just remember, just like with a real magnet, opposites are going to want to attract. So this side of the water molecule has a positive charge, and this side of this ammonia molecule is also electronegative. So this side of the water molecule is going to attract to this side of the ammonia molecule, causing it to have this hydrogen bond right here. Now remember, hydrogen bonds are not very strong bonds. They're fairly weak. So it's pretty easy to pull molecules apart that are bonded by hydrogen bonds. Now, all of the chemical biological processes that we're going to talk about, especially at a cellular level, deal with chemical reactions. Now, with chemical reactions, we're either using energy or we are transferring energy. Now, like putting the bond together, like catching the electron, you have to use energy for that. So if we're going to make something, say glucose, we're going to use energy to do that. Now, in order to get energy, we're going to break the bond. So like we're taking the glucose and breaking it down. Breaking it down releases the energy. Now, if you look, we have on one side of the equation, you have the reactants, what goes in to the reaction, and on the other side, if you want to think about the arrow as an equal sign, you have the products, what comes out of the reaction. Just like with math, you take whatever goes into the reaction has got to come out of the reaction. So here we have 2 molecules of hydrogen gas plus 1 molecule of oxygen gas. And on this side of the equation where our products are, we still have 2 oxygen atoms and still have 4 hydrogen atoms. So we have 4 hydrogens on this side, we have 4 hydrogens on the product side, we had 2 oxygens on the reactant side, and we still have 2 oxygens on the product side. So what goes in has got to come out.